as well. So with one example of position time graph, next we'll move to the velocity time graph. Okay, so for example, suppose if I take position along x-axis and y-axis and time along the x-axis. So this is what the position, and here it is negative position. So this is what the time. So simply you can take your own graph. You can draw however you want, but the conditions should be followed. So suppose I will take a graph like this somehow, and then I will take some straight line. Then I will put negative. Then again I will take a graph over here. Okay. So you may change the graph. However you want like that, you can draw the graph. So this is what I will give some numbers to this one. So this is what plus 5 position means 5 meter from your origin. This is what your origin, okay, or reference point. So here I will take time 2. Here it is 4. Here it is 6. Here it is 8. Here it is 10. Here it is 12. Okay, so this is what graph simply I have taken randomly. Okay, 10, 12. So here it is plus 5. If I take this, and this is going to be what, minus 5. Okay, so now if they may ask, or you can describe the motion, or they may ask you to find average velocity between average velocity of the body between t equals to 0 to t equals to say 2 seconds. T equals to 0 to t equals to 2 seconds. Or they may ask average velocity between t equals to means time of 6 seconds to t equals to t time of 10 seconds. Okay. So they may ask 12, whatever. You have to calculate everything, whatever you can calculate in this graph, you calculate yourself. Just I am taking two things over here. This is what they are asking. What is that? Average velocity between time equals to 0 to 2 seconds, and average velocity between time equals to 6 seconds to 10 seconds. Okay. So now, if I simply describe the motion, what is happening here? O is what? Reference point. So body started from reference point. In 2 seconds, it comes to the at a position 5 meter from the origin. Okay. So just then, if I show the motion, so this is what your origin. So what is happening? It is coming from 0 to 5. So it comes from 0 to 5 in this direction. So this is what 5. After 5 till 6 seconds it is at rest. Position is not changing. So it will be here only. Again after 4 seconds means from 6 seconds it is displacement or position is decreasing, means what? It changes direction. So it is coming back towards O. So it comes here 0, and displacement 0 means it reaches the origin or reference point. Again from here displacement is going to be a negative, or position is going to be on negative side, means from 8 to 10 seconds, from 8 to 10 seconds again it is coming in this direction. It is some minus 5. Then again what is happening? Its position is decreasing. Its position is decreasing in the sense what? It is again coming back. When it is 12 seconds, it comes back to the same position. Okay, this is what the actual meaning of this graph. Okay, so like this you have to analyze when you look at the graph. That imagination should come in your mind, that how the body is moving, from where it is starting, after some time how it is turning, or where it is taking the path, how its direction is changing. All those things you have to be imagine. Okay. So now I will calculate what is the average velocity between time equals to 0 to time equals to 2 seconds. So time is 0 here, 2 here. Okay. When t is 0, when t is 0, position is what? x is equals to 0. When t is 2 seconds, x is what? X is plus 5. Okay. So what is the average velocity? Average velocity is equals to what you can write, x at t equals to 2 minus x at t equals to 0 divided by t2 minus t1, that is t2 minus t1, t2 and t0. Okay, t equals to seconds, t equals to 0. So what is x when t is 2 seconds is plus 5 minus x is 0 divided by t2 minus t1, 2 minus 0, 2 minus 0, so this will become 5 by 2, that is 2.5 meter per second. Velocity is 2.5 meter per second. Okay, so you got the velocity here. In this, velocity is going to be what? Velocity is going to be 2.5 meter per second. Now what they are asking, velocity between t equals to 6 to t equals to 10 seconds, means from here to here. Over this journey they are asking t equals to 6 to t equals to 10. Over this journey they are asking what is the average velocity. Okay, so when t equals to 6, so x equals to what? X equals to plus 5. X equals to plus 5. When t equals to 10, x equals to what? X equals to minus 5. So when t equals to 10, x equals to what? Minus 5. Okay. Now, what is the average velocity? P average is equals to x at t equals to 10 minus x at t equals to 6 divided by t10 minus t6. Okay, so what is the x at t equals to 10? X at t equals 10 is minus 5. Remember, it is minus 5. Okay, minus what is the x at t equals to 6? X at t equals 6 is plus 5. So plus 5 divided by t equals to 10 minus 6. Okay, now so minus 5 plus minus, so minus 5 divided by 10 minus 6 is what? 4. So now, so 5 minus 5 will become what? Minus 5 will become minus 10. So 10 minus 6 is 4, 4 I will write as it is. We are getting negative sign. Remember, we are getting negative sign. So minus 10 by 4 means it will become what? Minus 2.5 again. Okay, minus 2.5 meter per second. Why we are getting negative sign? Because from here it started moving in opposite direction. Here it was moving along positive x-axis. Here it is moving along negative x-axis. Okay. So this is how you can calculate it from the graph. Then you may ask, what is happening between time is 2 to 6 seconds. What is happening here? Whether velocity is 2.5 or minus 2.5 or whether body is moving or not. So if you look at the graph, position is same. When t equals to 2 seconds, position is same. If you take in between some 4, position is same. 6, position is same. Position is not changing. Position is not changing means body is at rest. So that is why they are not asking average velocity between 2 to 6. Instead they are asking between 6 to 10. Why? Because body is in motion. Okay. So I hope you are getting why they are not asking here, or why graph is straight line parallel to x-axis, because position is not changing means body is at rest. Okay. So again, here body is moving, here position is changing means body is in motion. So you may calculate here also what is the average velocity. Okay. Remember, whenever you look at a graph, what they have asked, you calculate that one, then try to understand yourself what else they can ask. what I can get other things from this graph. Okay, so don't not only concentrate on the quotient, you concentrate, you try to analyze the total graph. Okay, so this is what how we can calculate what is the asked question, like average velocity from the position time graph. Now if I take a simple example, or if suppose I am having a position time graph over here, so x is along this and t is along this axis. So if I draw a graph like this, and if I ask you to describe the motion, what you can understand from this graph? What is the meaning of this graph? Whether this graph is acceptable or not, or what type of motion it is. So is it a circular motion, or what, uniform velocity or non-uniform? So what you can understand from this graph? If you look at the graph, position is changing as time is changing. That is absolutely correct. Our problem is still here, we don't have any problem. We may get confused for this path, so how it is changing, or we may start to analyze that. Try to understand here. If I take time at this point, say t equals to some 3, 4 or 5 seconds. So if I take a position, I will get two positions. One is here and another is here. At time equals to 5 seconds, I am getting two positions. That means for a same time, I am getting two positions of the body. Is it possible for a given time, is it possible for a body to be there in two positions? Is it possible for me for today to stand here at this time, at morning 10 o'clock, to be in the KCS main campus and in Aryabhatta campus? Is it possible? Can I do that at the meanwhile in two positions? It is absolutely what we can say. It absolutely not possible. Okay, that for a body, for the given instant of time, any body cannot be there in the two positions. But what graph is showing here is, at the same time t equals to 5 seconds, there are two positions. This is absolutely wrong. So this graph cannot be accepted. It means the graph is wrong. So it doesn't mean that when the graph is given we should start analyzing. We should understand what graph means, whether it is right or wrong. Okay. So this is all about position time graph. Velocity time graph. Velocity time graph. Okay, so very important. So what do we mean by velocity time graph? I hope now you only can use the definition for this. Okay, so what is that? If you have the graph, x-axis, y-axis. So along y-axis, what you are going to take? Along y-axis, you are going to take velocity. Along x-axis, you are going to take time. So why along time and why along y only? We have made some conditions ourselves. We have put some conditions ourselves in the beginning, means restrictions. What restrictions we have put? Along the x-axis, we are going to take the time independent variables. Or we are going to along the y-axis, what we are going to take? We are going to take some variables, means which are changing with the time. Time is what? It is not dependent on any other things. So those kind of things will take along the x-axis. Along the y-axis, the variable things or dependent things we are going to take. So that is why I am taking v along y-axis and time along the x-axis. Okay. So before only I told you, it doesn't mean that it is fixed. You have to take velocity only always like this. No, your axes are, or your system of axes are what it is, like empty bottle. Again and again I am telling you, what you put in the bottle, that will become. Okay. So this is what the origin. So then how we can define the velocity time graph for your theory exam purpose. So how we can define the graph in which in which the velocity is taken along y-axis. Velocity is taken along y-axis, and time is taken along x-axis. Okay, so that kind of graph is said to be what? Velocity time graph. Okay, so for example, here is a origin. A particle start moving. Here its velocity, after 1 second its velocity become 10 meter per second. After 2 seconds its velocity become 20 meter per second. After 3 seconds velocity become 30 meter per second. After 4 seconds velocity become 40 meter per second. Means what? It is accelerating. Velocity is increasing. Okay. So now if I plot the graph of velocity versus time. Okay. So take time intervals here 1, 2, 3, 4, 5. Okay. So velocities, you have to define the scale. I told you very beginning only. Without defining the scale, there is no meaning for the graph, even in your theory or practicals as well. So what I can define here is, I can define 1 centimeter equals to some 10 meter per second as velocity. Okay, this is 10 and this is what? 20, 30, some 40, 50, 60, so on like. So now if you plot the graph for this one, when time is 1 second, in 1 second it's accelerated to some 10 meter per second velocity. So for first second, when you look at your velocity was say 10 meter per second. So this is what the point you are going to get. So similarly, when you look at your velocity at time equals 2 seconds, it was suddenly 20. So your point, you will get it here somewhere. Okay. So this is what going to be the second point. Okay. So similarly, when time equals to 3 seconds, you are getting something here. Okay. This is what your third point. So similarly, for 4 second, speed is what? 40. So this is what going to be your fourth. So these are the points. So when you join, remember when t equals to 0, velocity is 0, means body is at rest. That also you have to consider. Otherwise, graph will not pass through the origin. So this is what when time t equals 0, it was at reference point. Origin is what? The reference point. So from there we have to start the graph. So you will get a straight line. Okay. I am not going to talk on how to draw the graph or what getting from the graph. Very important thing here is slope. And one more thing will come here, that is what? Area under the graph. Okay. So before that, so what this graph is suggesting? This graph is suggesting whenever you get this straight line, its velocity is what? Uniformly increasing. Means body is what? It is accelerating. Okay. Body is accelerating. So very important thing here is what slope will give you. What your position time graph slope gives, that is xt graph. Slope of xt graph is giving what? It is giving the velocity. Okay, we have discussed about that one. So now slope of velocity time graph, what this will give you? What this will give you? So for that I will take a slope over here. So this is what the slope. Okay. So slope. So this is what A, B, C. So how we can get the slope? Slope is equals to AB divided by BC. So AB divided by BC. So AB. So this I will take what? This is the P2 and this one I will take it as P1. Means it will come here P1. So time is what? This I will take as T2, this I will take as T1. You want this one, AB. AB length is what? This is V2 minus V1. So this will give you what? Delta V. So V2 minus V1 divided by. So what is this? T T2 minus T1. Instead of 4 and 2, generally I am taking T2 minus T1. So T2 minus T1. What is this V2 minus V1? It is the change in velocity. If velocity change is very small, so what I can write? I can write as delta V divided by, what is this one? Change in time, delta T. So this is what the slope. What is this? Change in velocity divided by time taken. Delta T is what? Time taken to change from V1 to V2. Time taken. So look at your last classes or remind what this is giving. So change in velocity divided by time is what? It is nothing but acceleration. Okay. So what we understood is slope of VT graph, slope of velocity time graph gives acceleration. Remember, very very important. So slope of VT graph always give you what? Give you the acceleration. So velocity time graph, one important result we got, that is what? The slope of velocity time graph. So velocity time graph, suppose you are having like this. So if you take a slope over here, okay, if you take the slope over here, so slope will give you what? Slope will give you acceleration. Okay. Here one more important result, one more important quantity, physical quantity we are going to get here. So that we will see. Suppose you are having velocity time graph over here. So this is what graph, and so if you take time t1 and t2, this is what time t1, this is what t1, and this is what t2. This is what going to be t2. Okay. So suppose now if we calculate, or total I will take from here to here, this I will take t. Okay. So from here to here I am taking time t, and till from here to here it is going to be what? It is going to be some displacement, velocity. So I will take it as v here. Okay. So obviously p is there in this direction, t is there in this direction. So I am taking instead of v, I will take from here to here. I will take v1 and t1. Okay. So what is this distance? This distance I will take it as delta v, and this distance I will take it as what? Delta t. Now instead of calculating the slope, if I calculate area under the curve, if I calculate this area, so what I will get? So how we can calculate this area? Suppose if you take A, B, C, this A, B, C is what? This is going to be a triangle. It is going to be a triangle. So if I calculate area under the curve, so what I will get? Area is equals to, area is what? Is it not area of the triangle ABC? So area of triangle ABC. So what is area of triangle? Area of triangle is half into base into height. So half into height into base. Okay. So now half you write as it is, no need to worry about that one. So area equals to, what is height? Height is AB. AB is what? AB is nothing but delta V. So I will write also AB into BC. So half into, what is AB? AB is nothing but delta V. What is BC? BC is nothing but delta T. Okay. Half into delta V into delta T. So now this is what area. Okay. So area is equals to some constant multiplied by delta V into delta T. Forget about this constant. So area is equals to, what is delta V? Change in velocity, or you can say velocity velocity into, this is what, time taken, time. So what is velocity into time will give you? Velocity into time will give you what? We know that velocity is equals to distance by time or displacement divided by time. Since we are in straight line motion, so most of time distance is equals to what? Displacement, if and only if body is not changing the direction. Okay. So now, so d equals to v into t. So what you will get? This is nothing but, this velocity into time is nothing but what? It is nothing but distance or displacement. Getting? So this is what area. So what important result we got here is area under the curve of VT graph always give you what? Always give you distance by displacement. Okay. So area under the curve of VT graph gives distance or displacement. Okay. So remember this point. Remember, very important, area under the curve of VT graph. Or here graph is like this. So what you are getting? You are getting the area of the triangle. Okay. Obviously, while calculating, you have to consider this upper. It doesn't mean that you have to leave that one. It is going to be there. Just to make you understand how you can arrive to the distance or displacement. I am just leaving that one. Otherwise, we have to consider. Suppose if it is graph is like this, so you are getting what? You are getting area under the curve, what? Triangle. Instead of that one, if graph is like this, if velocity is constant, if graph is something like this, so now what will happen? Till here, if you want to calculate till here, this is what the t. Okay. So this is what the delta v. Okay. So what will happen? This is going to be area under the curve. This is what going to be area under the curve. So now area under curve is what? It is nothing but a rectangle ABCD. So area of graph is equals to area of rectangle ABCD. Area of rectangle ABCD. So area of rectangle ABCD is what? Length into breadth. So what is that? You can take either AB or CD. AB into what I will take? I will take it as BC. So this is what? Velocity. This is what? Time. So that will give you what? That will give you area. So again area is what? This is nothing but what? V into T will give you what? Again distance bar, displacement. Okay. So this is how we can calculate. Okay. Or sometimes graph may be some different shapes. Okay. So sometimes graph may take like this also. So sometimes graph may be it may take like this. Graph will go here and it will come here. Okay. Now if you want to calculate total distance, so this is what the time. Okay. If this is the case, how we can what we can do here? So this is what we have to divide it. This is what going to be one triangle. And again from here to here you have to divide t equals to 0, t1, t2. Okay. Here what you will get? You will get half into this time, this displacement. After this, you will get one more area here. This is what? A rectangle. This is what? A rectangle. Now area under the curve is what? Area of triangle plus area of rectangle. Area of triangle plus area of rectangle. Okay. So both you have to calculate separately area of the rectangle and area of the triangle separately. Then what you have to do? Then you have to add them. You will get the total area, and total area will give you what? Total distance or displacement covered by an object. Okay. So we will discuss about these things. Different curves we will take. We will calculate the area. But as of now, you just remember area under the curve of VT graph will always give you what? It will give you the distance or displacement. Okay.